lists might not do everything that I want. They're nice because I can collect unlike things together. But maybe I want to perform some sort of mathematical operations. And so I'm going to actually add to the Python scripting language that I have here by importing a NumPy library. And a NumPy library is very similar to the math and functionality that you would see with, say, MATLAB. And because I like to, when I import libraries, I like to give them names, I'm going to import this library as NP. Now, I knew that this NumPy library existed, but a quick Google search would give you an almost infinite number of libraries to choose from. So this is just one that I happen to know that's great for those transitioning between MATLAB and Python, or who want to do any sort of mathematical operations with vectors or matrices. So the NumPy library comes with something called a NumPy array, and it takes inputs that are of type list. And so I can, this NumPy array, and I can print it, and that's going to be ANP. So now I have this new, that's not a list, it's a NumPy array that's made up of 1, 2, 3, 4. And you can see that in Excel, this 1, 2, 3, 4, this NumPy array actually looks the exact same as the list, and just like the list, each of these numbers is associated with some index, and just like the list, I can also access index 1, which will return 2. But unlike the list, the NumPy libraries are going to allow me to do math, particularly matrix multiplication or the dot product or anything associated with multiplying one vector or one matrix by another. So let's create a couple of new vectors. We'll call it C, and C will be made up of 3, 4, 5, 6, and D will be made up of 7, 8, 9, 10. So in this case, I have C and D, and they're both lists. And let's try to multiply C times D. Well, what you get is you can't multiply sequence by non-integer type list. And so these two things, I'm not allowed to do any sort of dot product or multiplication with these two items. But if I create NumPy arrays out of them, so CNP equals np.array, so I'm calling the NumPy library and I'm calling it an array, and it's going to take inputs of list C, so I'll pass it C, and I'll do the same thing with D, and I now want to print my NumPy array C times my NumPy array D, just so you can see what these things look like. What that does is this multiplication symbol will take every number and multiply it by every other number in the array. So for example, the first number is 3 times 7, it's 21, 4 times 8 is 32, 5 times 9 is 45, and then it returns this multiplication. So you can imagine over here me creating some sort of CNP, DNP, which is made up of 3, 4, 5, 6, and 7, 8, 9, 10. And this new thing, let's call that ENP, is going to be made up of this number times this number. So that's 21. Let's just print it over here so we can see what we're looking at. 21, 32, 45, and 60. So it's taking that asterisk, takes everything in one NumPy array and multiplies it by everything in the other NumPy array. If I want to do some sort of dot product with C times D, then I would actually write, let's do dot. Then I would actually write CNP, call the functionality that's built into the NumPy array, and so I'm going to call this dot. And I want to say CNP dot, and I want to dot that with DNP. And I will print what that looks like, and then it gives the dot product, which is basically saying multiply this number by this number by this number, and then we're gonna add them up, which is the definition of dot product, which is 158. And so I can do some sort of dot product with two vectors. I can also do some sort of matrix multiplication. Let's call this F. And F will be a list of 1, 2, 4, and it'll have 5, 6, 7, 8, 9, 10, 11, 12. A little bit of a big matrix. And right now it's a list, so if I print F, what you would see something is just a collection of lists within a single list. But if I convert that to a NumPy array, fnp, so I'm going to say np.array, inputs of type list, what you'll see is that it turns this collection of lists into something that has 4 rows, 1, 2, 3, 4, and 4 columns. And so now we're looking at something that looks a bit more like a matrix. And so fnp equals 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and then 13, 14, 15, 16. And now that I have this matrix, I can do matrix multiplication. So for example, I can take F and P, and I can use that asterisk, and I can multiply it by something of the same size. So let's say maybe C and P. And what you're seeing here is that everything in FNP, every element is again being multiplied by every element in CNP. If I wanted to do some sort of, again, matrix multiplication, then I would have to say FNP dot CNP, and now you're seeing a matrix multiplied by a vector, which returns some type of vector. Now, like lists, I can access things within this NumPy array. For example, if I want to access column 2, so I'm looking at FNP, and if I want to access column 2, each one of these rows is associated with some sort of index. And each column is also associated with some sort of index. So column 2 is this one here, is associated with index 1. And I want to grab all the rows. So to grab all the rows, I'm going to say FNP. I'm going to again use those brackets. And this colon says basically grab all the rows and then return column 1. And so that's going to return 2, 6, 10, 4. And you can imagine how you might want to grab even more than one column. So I want to grab column 1 and say column 2. And so you can go into your NumPy array and you can say again, grab all rows, but this time grab columns 1, 2, and so that you can think of this as being all rows, and it also stands for grabbing to something. So grab columns 1, 2, 3. And this is non-inclusive, so it's only going to grab columns 1 and 2 and won't grab column 3. So that'll grab these 2 columns here. You can do the same thing with rows. So if it's, for example, if I want to grab some row 9, 10, 11, 12, I now want to say, well, can you please grab all columns, but I want you to grab the second row because that's the index associated with this, or I'm sorry, it's row 3, index 2. And I'm going to grab all columns. And so that's going to return that 9, 10, 11, and 12. And finally, if I wanted to grab something like grab everything from row 2 to end, I could just say grab everything from row 2, and then it'll just be colon, just grab everything after it and grab all columns again. And that'll return these two rows here. I can do the same thing from the beginning. So for example, if I want to say grab everything from row 0 to row 2, I can say F and P. I want to grab everything before row 2 and all columns. And I'm sorry, it's not inclusive, and so this would actually have to be a 3, and then it would grab basically 0, 1, 2, 3, everything up into 3. So I can also grab subsets of this NumPy array. So for example, a subset might be something like, I want to grab these middle numbers here. And so I can combine the columns with the rows. So I can slice the columns and say, or I'm sorry, let's start with rows because it goes rows by columns. I want to grab rows 1 to 2. So I'm actually going to say 1 to 3 because again, that second number is not inclusive. And then I will also grab columns 1 to 3. And that'll grab that small subset of this array, 6, 7, 10, 11, and I can even call that subset by a different number or a different name. And so now this new NumPy array G is associated with 6, 7, 10, and 11. So if I wanted to create something of an arbitrary size, then I can create something called a zeros array, a NumPy zeros array, that takes inputs of size 5. So for example, I could say create this HNP that's made up of all zeros of size 5, which means it has 1, 2, 3, 4, 5 elements associated with it. And again, each of these elements is associated with some sort of index. A vector of, say, 1s. And I can again give it a type size, but it actually can also, if I were to Google the 1s array or the 0s array, it can also take something called a tuple, which will allow me, if this 5 is passing it only one number, the size of 5, this tuple can allow me to pass more than one number. And the tuple is associated with this parentheses. And maybe I can say, I want 5 rows and only 1 column. And so instead of zeros aligned in a row that's made up of 5 elements, this is going to allow me to have INP that's made up of 1s that's also 1, 2, 3, 4, 5 long. And so I can do some math with this as well. HNP times INP. And that's again going to multiply every member in this vector by every member in this vector, or I can do some sort of dot product with that. Which is basically the summation of this vector by this vector, because it's multiplied by zeros. Everything will basically be zeros. So let's try making this a little bit different. Let's make this 2 columns. So now I have this INP is made up of 5 rows and 2 columns. And sometimes it's important to grab the size of something. So I might want to check the size to make sure it's the appropriate length. And so I can say, if I were to look up more functionalities associated with this NumPy library, I want to grab the size of I and P and return it. And so what it returns is it says you have 10 elements in this array. So a NumPy array is made up of 10 things. Now, if I wanted to grab the size associated with a particular direction, so for example, the number of rows is associated with direction 0, then it's going to return a 5. So it says you have 5 rows. Or if I wanted to grab the size associated with the second direction, say the columns, it'll say look in the second direction and you will have 2 columns. And so just like indices started at 0 and were numbered by the length of all of the numbers of the number of elements in that array, directions are also associated with this 0, 1, 2, 3 sort of setup, where 0 corresponds to the number of rows, and then the columns are then associated with direction 1. And again, I'll bold these just so that's clear. And again, if you have an n-dimensional array, you can ask it to look at more directions besides just 0 and 1. Let's just write some quick comments here. So rows are associated with direction 0 and columns are associated with direction 1. And right now we have something called a list, which is associated with those brackets. And we also have something called a NumPy array, which we basically had to call. Whenever we call something associated with a NumPy array, we're going to be using this np dot to sort of name it, and that's because when we loaded that library, we named it NP. We also introduced this idea of a tuple, which is associated with parentheses. And now we're going to add one more item to this list of sort of these groupings, and that's going to be a dictionary. And a dictionary is going to be associated with two brackets.